Hi guys, so today we're going to talk about the matrix multiplication algorithms that we implemented for project one. So first, let's see the general code. So this is code we use to design the frame. First we initialize the MPI environment variables by using the initialization function and comrank and comsize from MPI library. Then we use word. So for the first processor, we just see what's the tie inputted for the command line. Then we generate two matrices of that size that are square matrix. Then after that, so we record the time. We start recording the time. We multiply. We do the multiplication, and then for process 0, we see what is the time after, and then we compute the total duration of the algorithm. So first for algo 2. So for process 0 actually compute a bunch of things. So first, process 0 has to compute the transpose of the matrix B, so which is matrix 2. So it transposes it and scatter each row for each processor. The row. So previously the column, and then now the row to the different processor of the matrix 2, and then so they don't move, and then for each iteration now we have to make A rotate, so the row must rotate, and so this is what we do. So at the first iteration, of course, M1 doesn't rotate. Then we scatter M1 rotated to the same way we scattered the transpose on M2 transpose, and then we compute we compute the product. So we do actually for each each column and row. So row we just do a scalar product between a dot product actually between the each row and column. So row actually of the thing of the two matrix. And then at the end, we gather the result. And so when we gather the result, we gather the result and put it at the right place in C, because we have to populate different places at different iteration. So this is all we do for algo 2. And then for the Fox algorithm, so we process in a different way. So first, the process 0 must broadcast so at the process 0 we start with doing some slice of B that are going to be actually the slice that are going to be used for the matrix multiplication. So we start by slicing 2 and broadcasting it to the processor. And then, so first we start by rotating B. We don't broadcast B first. We just broadcast some size block and row per block. And then after that, so for the process 0, we start rotating B depending on the iteration in the for loop. So the first iteration, of course, it doesn't rotate. Then we extract the good parts for A, because A also must move, but on the size of the row, and when B moves on the side, on the side of the columns. Move us from the side, so it must rotate. But anyway, we have to extract also the good row part for A. So we extract the good part, and then we compute. So we send we scatter actually the M2 rotated, the M1 subpart that need to be multiplicated. So then after that we do the matrix product. So it's a real matrix product because we have a small or subpart of A and subpart of B that are multiplied, and then those part actually are sent to the matrix, but differently to the previous algorithm. We populate all the matrix with number the So we populate the result matrix with results, but we populate all the matrix, and that's the difference with the one of the difference with the other algorithms.
The result of both algorithms. For algorithm 2, we can observe the runtime behavior that is decreasing. That means that we got good results about the parallelization. For the speed up, we can observe that has an increasing behavior, but until 16 processors, we got that a decreasing behavior. The max value that we got for the speed up is between 4 and 5. For the efficiency, we observe a decreasing behavior. Uh, all the values are below 1, so this is not good. That was not a good result. For Fox algorithm, the runtime as the algorithm 2, we observe a decreasing behavior, something that is good for the parallelization. In the speed up, we can observe a max value of 20, and we can observe too that we have a high speed up until 25 processors. After that, we can observe a decreasing. That could be because the communication with the processor can needs more time to send back the information. And for efficiency, we observe that the values are over 1 with a max value of 2. We have a peak in the with 4 processors. After that, we observe a decrease in behavior. So as a conclusion, we observe that Fox algorithm is better because we got in the speed up, we have a higher speed than algorithm 2. And for 25 processors, we got the best performance. And the efficiency was over 1, and we got a max of 2 in the efficiency. So that shows better results than the algorithm 2.